Good morning. Today we are going to discuss about the working principle operation of DC generator and constructions. The first of all, what is the machine? The electrical machine is it's convert to one form of energy into another form of energy. Electrical machines are there are two types of machines. The first one is static machines and rotating machines. The static machines there is no rotating parts. The examples for static machines are transformers. In rotating machines, there are many important two parts of the rotating machines are starter and rotor. They're divided into two types, the DC machines and DC AC machines. Again, DC machines are divided into two types, DC generators and DC motors. And again, AC machines are divided into two types, synchronous machines and asynchronous machines. Asynchronous machines are also called as induction motors or induction machines. Synchronous machines is also divided into asynchronous generators and synchronous motors. Now, the first of all, what is the DC machines? Basically, the DC machines are divided into two parts. The two machines. The first one DC generators and then DC motors. Okay. There are again generators that are divided into two types. The first one is AC generators and DC generators. The generator means which convert to mechanical power to electrical power and mechanical energy to electrical energy. Which machine is convert to mechanical energy to electrical energy? That machine is called as a generator. And again, motor. The motor is it's convert to electrical power to mechanical power, electrical energy to mechanical energy. Which machine is convert to electrical energy to mechanical energy? That machine is called as a motor. These generators are the first generators. The generators are is based on the fundamental principle of Faraday's laws of electromagnetic induction. Okay, the Faraday's laws of electromagnetic induction. The first one is the first law is the conductor, current carrying conductor moves in a magnetic field. It cuts the magnetic lines force, due to which the EMF induced in the conductor. That is the first law. Okay, whenever current carrying conductor is direct cuts the magnetic field, that EMF is induced. That is first law. The second law is that the EMF is directly proportional to rate of change of flux. Okay, EMF is directly proportional to d pi by dt. The first law is whenever current carrying conductor moves in a magnetic field, it cuts the magnetic lines force, that EMF is induced in the conductor. The second law is the EMF is directly proportional to d pi by dt, the rate of change of flux. There are two important parts of the generator is the magnetic field and the conductors. Okay. The generator is it's convert to mechanical energy to electrical energy. That machine is called a generator. The generator is DC generators and AC generators. The difference between the DC generator and AC generator is the generator which convert the mechanical energy into DC form of electrical energy. That called as a DC generators. AC generators means the generator which convert the mechanical energy into AC form of electrical energy is called AC generators. But both machines, the DC generators and the AC generators, working on the principle of Faraday's laws of electromagnetic induction. Okay, in 1831, Michael Faraday is this English physician is given one of the most basic laws of electromagnetic induction. That called as Faraday's laws of electromagnetic induction. The Faraday's laws of electromagnetic induction is the EMF. Whenever current carrying conductor cuts the magnetic field, that EMF is induced in the conductor. That is the first law. The second law is EMF is directly proportional to d pi by dt. Okay, this is a basic diagram of DC generator. Okay. The DC generator is it's converted to mechanical energy to electrical energy. There are two types, AC generators and DC generators. The main important parts of the generator is uniform magnetic field and system conductors and relative motion between the magnetic field and conductor and conductor. Okay. The main working principle of DC generator is Faraday's laws of electromagnetic induction. That is the first law. The first law is whenever conductor cuts the magnetic flux, the EMF induced in the conductor. Okay, the second law is the magnitude of the induced EMF E is directly proportional to rate of change of flux linkages. E is directly proportional to d pi by dt. One more law is Lenz law. The Lenz law is the induced current is always flows in a direction such that the opposite in change in the changes which produced it. That is called as a Lenz law. And again, the generator is working of principle of operation of this generator is Fleming right hand rule. DC motor is Fleming left hand rule. The Fleming left hand right hand rule, there are three thumbs. The three thumbs indicates the first one is thumb. So the thumb finger indicates represented the direction of motion of the conductor. The first finger, the forefinger, is in representation field. The second finger is middle finger. The middle finger is representation as current. The forefinger, the thumb finger is indicates the represented the direction of the motion of the conductor. The second finger is representation of the field, magnetic field. The third finger is representation of the current. Okay, the EMF. DC generator is converted to alternating current in generated in unidirectional current. Okay, there are important parts of the this is there are important parts of the DC generator is first one is yoke, the second one is poles, the third one is field winding, the fourth one is armature, the fifth one is commutator and brushes, gear, the last one, sixth one is bearings. Okay, in this figure, the first one is yoke. Okay, this is a part of the generator is yoke. The second one is poles. The number of poles in this generator is four. Okay, this one is field winding. Okay, the field winding connected to all the four poles. The next one is armature. This one is called as armature. The next one is commutator. The inner part of the armature is commutator. The last one is bearings. The first one is yoke. This yoke is called as a frame. Okay, this yoke is production to the rotating and other parts of the whole machine. Okay, the yoke is iron body. Okay, it is made from iron and which is provided in the part for the flex and mechanical support for the pole. Okay, this yoke is also called as a frame. This yoke production from the rotating and other part of the machine. And yoke is iron body. It provides the part of the flex and mechanical support for the pole and the O. Support for the pole. The second part of the generator is pole. Okay, this is called as a pole. The number of poles in this machine is 4. 1, 2, 3, 4. Okay, the pole carry the field winding. Okay, this is called as a field winding. Okay, this is called as a field winding. And rectangle cross section and laminated to reduce the heat losses and 50 to yoke through the bolts. Okay, this pole is fitted to the to yoke through the bolts. Okay, next one is field winding. Okay, this winding, the winding is around the pole is called as a field winding. It is set of coils. Okay, steady current flows through this produce requires a magnetic field. The fourth part of the generator is armature. The armature is it is a coil wound around the metal core and mounted between the poles of magnetic induction. The next one is commutator. The main part of the generator is commutator. It's commutator is converted to alternating current to direct unidirectional current. It's converted to AC to DC. And the one more important point of the commutator is the commutator reverses the direct connection of the coil. The external circuit each time of the current reverse. The next sixth part is brushes. The brushes is these brushes used for these connect the commutator and the external circuits and connect the current is induced in the armature to coil to the external circuits and the collect the current from the commutator. Okay. One yoke is also called as a firm. It's provided the protection to rotating other parts of the emotions. The yoke is iron body. It provides the mechanical support to the front coils. It is made from yoke. The material is used for the yoke is cast iron, silicon steel, and cast stone. The next one is second part is pole. Pole produces the magnetic flex. The flex when the field winding is agitated, and the material for pole is cast coal. The next one is field winding. The field winding also called as excitation winding. The current is passed through the field winding in a specific direction to the pole. The metal is used for the field connected to the copper. The next one is armature. The armature is all these slots are parallel to the soft axis. The armature connectors are placed in these slots. The armature cores provides a low reluctance path to the flex produced by the field winding. Okay. The next one is commutator. The commutator means it's convert to alternating to and DC current and collect the current from the armature connectors and convert to AC to DC. Okay. The next one is rotor is moving part of the generator. The rotor is rotated because of wires and magnetic field of the motor. And the arrangement shows that the torque is developed by the rotor axis. The next one is working principle, working of DC generators. The before topics is the construction of DC generators. What is the important parts of the DC generators? The next one is working principle of DC generators. Okay, the DC generator is, it's converted to mechanical to energy. The DC generator is a it depends upon the Faraday's laws of induction motion. Faraday's laws of induction motion. Faraday's law of electromagnetic induction. And the first law is whenever current carrying conductor cuts the magnetic field, the EMF induced in the conductor. The second law is E is directly proportional to d pi by dt. Okay, then now DC current is generated by the DC generators. Now the working of working generation of in DC voltage. These two are two poles. Okay, let us consider these two are two poles. This one is flex. Okay, there are four directions. The first of all, in the generation of AC volt, in the generator to the first of to generate the AC voltage. The AC current is converted to DC current. The commutator is converted to AC to DC convert. Okay, now first of all, there are two poles, north pole and south pole. When the rotating form, the 0 to 360 degrees, in the figure A, okay, the figure is A, the coil stationary, the EMF is generated is null. So the coil is zero position. The coil is zero position. When the coil is stationary, the EMF is generated is zero. When the coil is rotating at 0 to 90 degrees, the flux is generated the more. Okay, the flux is resulting in the AC voltage at output. The flux is EMF is generated is more d pi by dt. The flux is more, so EMF is more. When the coil is reaches at the off cycle rotation of the complete, now the same the EMF is generated is zero. Again, the coil is 180 to 270 degrees. 170 270 degrees. There are again the EMF is generated is more, but in the reverse direction. The next one is coil reaches to 360 degrees. Once the reaches the coil is 360 degrees, at the only one reaction at the coil. The result is again 0. Okay. That EMF is called d pi by dt. E is directly proportional to d pi by dt. Now we generate this way from the AC voltage. The commutator is converted to AC to DC voltage. Okay, thank you.